Hi everyone, welcome to CAIE Science. Today we will be solving May-June 2023 variant 22 of 9701. Okay, so let's begin. Question number 1. The melting points of some solids are shown in table 1.1. Part A. State the type of bonding present in magnesium and in sodium chloride. So, so the bonding in the magnesium is a metal, so the bonding in the metals is metallic bonding. So metallic bonding magnesium, and you know that this sodium chloride is an ionic compound, so ionic bonding. Okay, so now moving towards next part, explain the difference in the melting points of magnesium and sodium chloride. So if you see here, the melting point of magnesium is lower than the melting point of sodium chloride. So it means that there are stronger bonds in sodium chloride than the bonds in magnesium. Okay, that's why the sodium chloride requires more energy to break those bonds. Okay, so bonds in sodium chloride are stronger than bonds in magnesium. Okay, explain the difference in the melting points of phosphorus and sulfur in terms of structure and bonding. Okay, so sulfur, this is phosphorus and this is sulfur, and sulfur has greater melting point. So if you see that sulfur exists as S8 and phosphorus exists as P4, so it clearly means that this sulfur has more electrons. So if there are more electrons, then it will have more induced dipole forces. So it means this molecule will have a higher melting point. Okay, so it will require more energy than phosphorus. So that's the difference. You have to explain this. Okay, so acid, or you can say sulfur, has more electrons. Okay, more electrons, so has stronger induced dipole forces, or instantaneous dipole force. Instantaneous dipole instantaneous dipole induced dipole forces. Okay, that's why this sulfur has greater melting point than this phosphorus forces. Now define electronegativity. So it's the ability of an atom to attract electrons to itself. Okay, or you can also write that the power of an atom to attract the electrons to itself. So now explain why electronegativity increase across the period. So if you see that across the period, this the radius of atom decreases because the nuclear charge increases, and the nuclear charge, which is a proton number, because the proton number will increase across the period, so increases the nuclear charge increase. So this there is more charge density across the period because the shell is same, so shielding factor is constant. Okay, so that's why the electronegativity ability of an atom to attract the electrons increase. Okay, because there is more charge density, so the incoming electron will be attracted more. Now, how we will write the answer? Explain why electronegativity increase across the period. So there is an increase. There is an increase in nuclear charge. Okay, so, and similar shielding factor. Similar shielding factor. So increase in nuclear attraction. Increase in nuclear attraction for bonding electrons. For valence, or you can say, or for valence electrons. Valence electrons. Okay. Now moving towards next part. Name the strongest intermolecular force that exists between the ammonia molecules. So in ammonia, this ammonia contains hydrogen bonding. The hydrogen bonding can only be in fluorine, oxygen, and nitrogen. Okay, and they because there is nitrogen present in ammonia, so and hydrogen, so there will be an hydrogen bonding. So the strongest intermolecular force in this ammonia is hydrogen bonding. Okay, now draw a diagram to show the formation of strongest intermolecular force between two molecules of ammonia. Include any relevant lone pairs of electrons and dipoles. So how you will show this uh, hydrogen bonding? So this is the first molecule of ammonia, and this is the second molecule of ammonia, and here you have a lone pair and you have a partial positive charge, and here you have a lone pair, partial negative charge, partial negative charge, and partial positive charge. Okay, so this hydrogen bonding is from the partial positive charge on this hydrogen to the lone pair of nitrogen. So you will show this hydrogen bonding between these. Okay, so this is your hydrogen bonding. So that's how you will show the hydrogen bonding between two molecules of ammonia. Okay, now moving towards next part, the melting point of ice and ammonia are shown in table 1.2. Okay, so ice has a greater melting point. That means it has more and stronger intermolecular forces. So what is the formula of ice? It is H2O, ammonia adds NH3. So this water molecule also has hydrogen bonding. Suggest two reasons for the difference in melting point of ice and ammonia. So now both of them contains hydrogen bonding, but the hydrogen bonding in this water or ice is stronger because this oxygen, if you see in the periodic table, this oxygen has more charge, nuclear charge, than this nitrogen. Okay, that's why it is more electronegative. Oxygen is more electronegative, so it will have more, you can say, electronegative, so it will attract electrons more, or there will be more attraction to the outer shell electrons. Okay, and also this oxygen has more electrons. Okay, and if you see, there are two lone pairs on this oxygen in water or ice, and there is only one lone pair on this ammonia. So there are two lone pairs, so it means that one molecule of this ice can form two hydrogen bonds. This one molecule of ammonia can only form one hydrogen bond, and this water molecule can form two bonds of hydrogen. So the hydrogen bonding in this ice will be stronger than in ammonia. Okay, so these are your reasons. So first reason is that oxygen is more electronegative electronegative than nitrogen, and there are two hydrogen bonds two hydrogen bonds per water molecule. Okay, molecule, and one hydrogen bond per ammonia. So that's why this water or ice has a high melting point than ammonia. Now moving towards question number 2. Chlorine is a reactive element. Okay, it forms many compounds. Okay, complete the table 2.1 to show the maximum oxidation number of elements sodium to phosphorus in their chlorides. So the formulas of these chlorides, for the sodium chloride formula is NaCl, and for magnesium chloride it's MgCl2, and for aluminum it's AlCl3, for silicon it's SiCl4, and for phosphorus it's actually PCl5 or PCl3, but you will write PCl5 over here. Okay, so now compare the table to show the maximum oxidation number of elements nitrogen to phosphorus. Okay, so the oxidation state of sodium in the sodium chloride is +1. Okay, and for this magnesium it's +2, for aluminum it's +3, for silicon it's +4, and for phosphorus it's +5. So these are your maximum oxidation numbers. Now state what determines the maximum oxidation number of an element in period 3. So the number of outer shell electrons actually determine the maximum oxidation number. Okay, because if you see in sodium there is only one electron in its outer shell, and there are two electrons in magnesium in its outer shell. For aluminum it's 3, for silicon there are 4, and for phosphorus there are 5 electrons. So it means that the number of valence electrons determine the maximum oxidation number of an element. Okay, so number of valence electrons determines the maximum oxidation number of elements in period 3. An excess of cold water is added to the chloride of silicon. Okay, write an equation for the reaction between an excess of cold water and the chloride of silicon. Now silicon, this is silicon chloride of silicon 4 chloride, and this is a covalent compound, so it will be hydrolyzed by water. Okay, so it will not dissolve in water, but it will react with. So when this silicon chloride sorry silicon 4 chloride reacts with water, it will form silicon dioxide, or you can say it silicon 4 oxide, plus it will form HCl. Okay, so it means this is the equation for the hydrolysis of silicon 4 chloride. Okay, now balance the equation, so that's your final equation. Now suggest the pH of the solution produced in B. So if you see there is HCl produced, so it means the pH, and this HCl is a strong acid, so it means the pH will be between 1 to 3. So you can write it as 1, or you can write as 2, because the pH of strong acids are 1 to 3. Now part C, An excess of cold water is added to the chloride of phosphorus. Okay. Write an equation for the reaction between an excess of cold water and the chloride of phosphorus. Now this PCl5 chloride of phosphorus is also a covalent compound and it will also be hydrolyzed by water. So it will form H3 phosphoric acid H3PO4 plus HCl. Balance the equation and you will get this balanced equation. Okay, balancing an equation is a must because it also has a mark. Okay, 1 mark is for balancing the equation in some papers. Okay, so that's your balanced equation and you can see that this is the hydrolysis of PCl5. So suggest the pH of the solution produced in T1. So you can see that two strong acids are produced, which one is phosphoric acid and the other is HCl. So the pH will be 1 to 2. Okay, now part D. Write an equation for the reaction of chlorine with water. So when this chlorine reacts with water, it forms water. Actually, it's the reversible reaction. Okay, this is a real reversible reaction, and the HCl and HOCl, these both are formed. Okay, and when the UV light is you can say when UV light is it is exposed to UV light, it forms HCl plus oxygen. Okay, but you will write this equation when this water and chlorine react, it will form HCl and HOCl. Now write an equation for the reaction of chloride with hot sodium hydroxide. So now the chlorine reacts with sodium chloride in two different ways because the conditions for those two ways are different. Here it says this is hot sodium hydroxide. So when this chlorine reacts with hot sodium hydroxide, it forms sodium chloride plus sodium 5 chloride plus chloride 5. This is sodium chloride 5 plus water. So now balance the equation and this is your balanced equation. And when this chlorine reacts with cold sodium hydroxide, it forms sodium chloride plus NaClO plus water. Okay. So these are your two equations for the reaction of chlorine with sodium hydroxide, but you have to see that whether it's a cold or hot sodium hydroxide. Now part E. Bleach is used as a cleaning product to kill bacteria. It is made by adding compounds like sodium chlorate 1, this is NaClO, to water. Okay, so identify the formula of the ion present in bleach that kills these bacteria. So it's actually the ClO only, this formula of this ion. This ion actually kills the bacteria and the bleach. You have to remember this. Now sodium chlorate 1 reacts with hydrogen peroxide to produce sodium chloride, water and oxygen. So construct an equation for this reaction. So when this sodium chlorate 1 reacts with hydrogen peroxide, so it forms sodium chloride, water and oxygen. This is your equation. Now this equation is already balanced. Okay. Now a sample of bleach W contains an unknown concentration of sodium chlorate 1. Okay. So when 10 cm cube of W is diluted with water to make a total volume of 100 cm cube of bleach solution. Okay, 25 cm cube of this diluted bleach solution is added to an excess of hydrogen peroxide. Okay, so hydrogen peroxide is in excess, and the volume of gas produced, this gas, oxygen gas, will be produced, because this is your equation when this sodium chloride 1 reacts with hydrogen peroxide. So the volume of gas may produced measured under room conditions and under room conditions. Okay. Now the experiment is repeated, and on average 25 cm cube of diluted bleach solution produces 45 cm cube of gas. Okay. So now calculate the concentration in gram per dm cube of sodium chloride 1 in W. So now you will begin with this gas, the volume of gas which is produced. So now firstly you will calculate the moles of oxygen that are produced. So moles of oxygen produced are, it's the formula to calculate the moles of a gas is volume is equals to 24 into n, which where n is actually the number of moles and this volume is in dm cube. Okay, and this 24 is the standard condition, standard volume under room conditions. Okay, and there are room conditions because told you that the volume of gas is produced under room conditions. Okay, so if you make the n subject, so the volume which is 44, but you have to make it into dm cube, so you will multiply it with 10 to power minus 3 divided by 24. Okay, so you will get the moles of oxygen. So it's actually going to be 1.75 into 10 to power minus 3 moles of oxygen. Okay, so now you will calculate the moles of this W, or you can say the moles of this NaClO, because W contains this sodium chloride 1. Okay, so you will calculate the moles of this sodium chloride 1 in the from the ratio of this oxygen from the equation. So you can see that the oxygen and the sodium chloride 1 are in 1 over ratio. So the moles of W in 25 cm cube, because it didn't use the 100 cm cube, it used 25 cm cube of this solution. So the moles of W in 25 cm cube is equals to 1.75 into 10 to power minus 3 moles. And now you will calculate the moles of W in 100 cm cube of W in 100 cm cube. So it's actually going to be 1.74 into 10 to power minus 3 into 4. Okay, because this 25 multiplied by 4 is equals to 100. Okay, so if you multiply this with 4, so you will get 7 into 10 to power minus 3 moles. Okay, now this volume is, now you have calculated the moles and the volume is given, which is 10 cm cube of W. Okay, so now we will calculate the concentration of W, or this sodium chlorate in W. Okay, so 10 cm cube of this W is used, so you will calculate the concentration of sodium chlorate. Okay, concentration of NaClO in W is going to be, the formula is actually the N is equals to CV, and where N is moles and C is concentration and V is volume. Okay, now this you have calculated the mole, so you want to calculate the concentration, so formula is going to be C is equals to N upon V. Okay, so moles, you have calculated the moles, which is 7 into 10 to power minus 3. Now you have this volume is given to you, which is 10 cm cube. This is 10 cm cube of W. Okay, so 10, but you have to convert this 10, this 10 is in cm cube, you have to convert it into dm cube, so you will multiply here, the 1000 will be multiplied here, or you can say this 10 to power minus 3 will be multiplied in the denominator. So you will get the concentration in mole per dm cube. So it's actually 0.7 mole per dm cube. But I told you that the concentration should be in gram per dm cube. So to convert the moles into grams, you know that moles is equals to mass upon mr, and this mass is in grams. So to convert it into mass is equals to mole multiplied by mr. So now you will calculate the mr of this NaClO. So if you calculate the mr of NaClO is equal to 23 plus chlorine is 35.5 plus oxygen is 16. Okay, so you will get the final uh, mr, 23 plus 35.5 plus 16. So it's actually 74.5. Okay, so this is your mr. Now you will multiply this mr with 0.7, so you will get the concentration in gram per dm cube. So it's actually 52 point um, 52 point, you can say 2, 52.2. So this is your final concentration in gram per dm cube, 52.2. Now moving towards question number 3. Figure 3.1 describes a sequence of reactions that can be used to produce a food additive compound Y. From this, you can say this is ethanol. No, this is chloroethane. Yeah, this is chloroethane. Now, this chloroethane produces this propanitrile, and then this produces a propanoic acid. Now, let's state the reagents and conditions for step 1 in figure 3.1. So, to produce this propanitrile from chloroethane, this is actually a nucleophilic substitution reaction, and the conditions are actually KCN or NaCN, KCN or NaCN in ethanol plus heat. Now give the systematic name of X. So it's actually propanitrile. Propanitrile. Now identify the type of reaction that occurs when this dilute acid is added to X in step 2. So it's actually the hydrolysis. It's the hydrolysis of cyano group. Okay, acidic hydrolysis. Now when this propanitrile is hydrolyzed, it forms propanoic acid. Okay. Now in step 3, Y and a gas are produced. Construct an equation. So now you can see that the metal is reacting with acid. So when this acid reacts with metal, hydrogen gas and a salt is formed. So it's actually going to be CH3, CH2 and COOH plus calcium. So it will form this salt. You will form calcium propanoate. Okay, so its formula is going to be CH3, CH2, COO and plus hydrogen gas. Okay, you have to balance the equation. So this is your balanced equation. Okay, now when this propanoic acid can also be formed from propan-1-ol and potassium dichromate 7. Okay, state the conditions required. So the conditions required are this potassium dichromate should be in acidic form and the heat under reflux. Okay, so acidified and heat under reflux. heat under reflux. Now, part C, complete table 3.1 to show the number of sigma bonds and pi bonds present in the molecule of X. So the molecule of X, this is actually propanitrile. So to draw this, the displayed formulas, so it's CH3, CH2, and P triple bond N. So this is your formula of the displayed formula of X, which is propanitrile. Okay, so if you see the number of sigma bonds, so 1, 2, 3, 4, 5, 6, 7, and there will be a sigma bond in this triple bond, so 8. There are 8 sigma bonds, and this triple bond has 2 pi bonds, because when there is one pi bond, the double bond forms, and there is triple bond, so there are 2 pi bonds. So these are your number of sigma bonds and number of pi bonds. Now moving towards question number 4. In industry, ethanol is made by reacting ethene with steam in the presence of phosphoric acid. Okay. Use the bond energy values in table 4.1 to calculate the energy change for the reaction 1. So energy change is equal to the energy of reactants minus the energy of products. Okay. So energy change is equals to energy of reactants minus energy of products. So you will first find the energy of reactants, and then you will find the energy of products, and you will then subtract these two to get the energy change. Okay, you are given the bond energies. So if you see the structure of ethene, this is CH2H4. So it's actually, the structure of ethene is like this. Then you have the water molecule, and it has a structure like this. There are two OH bonds, and then you have finally ethanol. So it has a displayed formula like this: CH2, O, and H. Okay, now I have drawn these displayed formulas because now you will have a better understanding how you will use these bond energies to calculate the energies of reactants and products. Okay, so now let's use the bond energies values in figure in table 4.1 to calculate the enthalpy change. Okay, so first let's we calculate the energy needed to break bonds. Okay, energy needed to break bonds, or you can say the energy of reactants. Now in reactant, firstly you have a one carbon double bond, so the double bond has an energy of 610. Now plus you have one this, there are 4 CH bonds. Okay, so if you see um, okay, so there are 4 CH bonds in this ethene, CH, and this CH bond, and this CH bond, and this CH bond. So there are 4 CH bonds, and this CH bond has a energy of 410. So 410 into multiply by 4, because there are 4 CH groups, 4 CH bonds, sorry. Now you have 2 OH bonds, you can see. So and the bond energy of OH bond is 460, so into 2. So this is your energy of reactants, or you can say energy needed to break bonds. So it's actually going to be 3170. Okay, now you will calculate the energy produced when bonds form. When bonds form, So it's actually the energy of products. So if you see, there is one carbon carbon single bond, and it has a energy of 350. 350 plus there are 1, 2, 3, 4, and 5. There are 5 CH bonds. Okay, so CH bond, the CH bond is an energy of 410 into 5. Okay, and then you have this bond energy, carbon oxygen single bond, and it has a bond energy of 360, plus you have this OH bond, one OH bond, and it is a bond energy of 460. So these are your energies for the products, and it's actually a 3220. Okay, now the formula is written: enthalpy change or energy change is equals to reactants, energy of reactants minus energy of products. So it's actually a negative of 50. So this is the energy change of this reaction. Okay, I hope you have understood it. Now part B. Reaction 1 reaches equilibrium at a constant temperature and pressure. Okay, deduce what effect increasing the pressure will have on the amount of ethanol produced in the new equilibrium mixture. Use Lee Chatwiller's principle to explain your answer. So if you increase the temperature, so if you so you will see that how many number of gaseous moles are there. So if you see, there is only one gas mole on the product side, and there are two gaseous moles on the reactant side, or you can say on the left side. So if the pressure is increased, the equilibrium will shift to the uh, right side, because there are less number of gas moles on the right side. Okay, so the you can say the yield of this ethanol will increase. Okay, if you increase the pressure, so this yield, or you can say amount of ethanol will increase. Amount of ethanol increases because the equilibrium shifts to the right side. Equilibrium shifts to the right side, to the right side, because there are because there there are fewer gas moles to the right side. Okay, there are fewer gas moles on the right side. On the right side. Now, part C, the mechanism of the reaction 1 can be described in 3 steps. Okay, so step 1 and step 2 for the reaction 1 are shown in figure 4.1. So firstly, this ethane molecule reacts with the catalyst H3PO4, phosphoric acid. Okay, so how this reacts, the mechanism is shown to you. Now describe the behavior of this phosphoric acid in step 1 in figure 4.1. Explain your answer. So if you see what is happening in step 1, this phosphorus, you have to identify the behavior of uh, this phosphoric acid. So if you see that it has donated its H, or you can say it's H plus ion, or you can say proton. So the proton donors are actually the acids. Okay, so the behavior of this H3PO4 or phosphoric acid in step 1 is as acid. So the behavior is as an acid because it has donated a proton. Okay, or H plus ion. Now identify the species that behaves as an electrophile in step 2 in figure 4.1. Explain your answer. So the electrophile is going to be the one with deficiency of electrons, and it will accept a lone pair of electrons. So if you see in step 2, this is going to be your electrophile because it has a positive charge and it has a deficiency of electrons, and it is accepting a lone pair from this water molecule. So the this is the electrophile is actually CH3 CH2 plus. Okay, so CH3 CH2 plus. This is your electrophile because it accepts a lone pair, or you can say a pair of electrons. Pair of electrons. Now, moving towards next part 3, complete table 4.2 to show the mechanism for the step 3 of reaction 1. Include charges, dipoles, lone pairs of electrons, and curly arrows as appropriate. Now, in step 3, uh, this uh, this acid, there is a lone pair on this oxygen of this phosphoric acid, because you can see that there it has a lone pair, okay, in this phosphoric acid, and this lone pair will actually attract this phosphoric acid is actually the catalyst, and a catalyst will reform like this. Okay, so it will accept a hydrogen. So now this will attract this hydrogen. Okay, and this hydrogen will lose its electrons, and it will form positive ion. It will lose its electrons to oxygen, so it will form this ethanol, and this phosphoric acid will be regenerated. Okay, so that's your final mechanism. Okay, now moving towards next part 4, describe how a catalyst affects a reaction. So catalyst actually increase the rate by producing an alternative pathway with a lower activation energy. A catalyst increases rate by producing an alternative reaction pathway with lower activation energy. Okay, so this is your the use of catalyst. Okay, now use figure 4.1 and 4.2 to justify why this phosphoric acid is described as a catalyst in reaction 1, because this phosphoric acid is regenerated. You can see from the mechanism. Okay, so uh, you can see that this phosphoric is regenerated, so it is uh, that's why this is a catalyst. Okay, it is regenerated or reformed. Okay, it is generated. Now propene also reacts with steam. Okay, and a mixture of organic products is produced. Okay, explain why the propane 2-ol is produced in higher concentration. So now if you see, this is your propene, this is your structure of propene, CH3, and when it will react with the steam, it will form two alcohols, CH3 CH CH, whether the OH group will be attached over here on the first carbon or in the second carbon. CH3 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 CH and OH. So but this propane 2, this propane 2-ol will be in higher concentration because it will form a secondary carbocation. Okay, with this carbocation CH3 CH and CH3 plus, this Cl plus. Okay, so this carbocation is more stable. This is actually a secondary carbocation, and it is more stable than the primary carbocation. So that's why this propane 2-ol will be produced in more concentration. Okay, so because it produces more stable carbocation. Okay, so this produces more stable carbocation of because of more positive or electron donating effect, positive inductive effect of more alkyl groups. These alkyl groups are actually the electron donating groups. Okay, alkyl groups. So if there are more alkyl groups, so they will donate more electrons. So this plus positive charge will be stabilized. Okay, so this carbocation is likely to form. So that's why this propane 2 will be in higher yield. Okay, now part D, describe the covalent bonds present between the carbon atoms in ethene molecule by completing the table in 4.1. Okay, so in ethene, CH, C double bond and CH, this is the molecule of ethene. So type of orbitals involved in bonding. Okay, so the types of orbital in sigma bonds. In sigma bonds, there are actually uh, sp2 orbitals. Okay, sp2. And in pi bonds, the pi bonds is between the p orbitals. Okay, the sigma bonds are between the s and p orbitals, and these pi bonds are between the p orbitals. So there will be a p orbitals, but you can say that there will be 2p because this carbon has 4 electrons, sorry, 6 electrons, and if you write its electronic configuration, it's actually 1s2, 2s2, and 2p2. Okay, so there will be 2p. Okay, pi bonds will be in 2p. Now how the orbitals overlap? So sigma bonds actually have a head to head overlap, or you can say direct overlap, head to head on. And in pi bonds there is sideways overlap. Now moving towards next question. Question number 5, describe structural isomerism. So it's actually the molecules with same molecular formula but different structures. Okay, molecules with same molecular formula but different different structural formula. So these are the structural isomers of each other. A and B are structural isomers with molecular formula C5H10O. Okay, now they are both straight chained molecules with only one functional group. Okay, now figure 5.1 describes observations when separate samples of A and B are added to different reagents. Okay, so when 2,4-DNPH dinitroflan hydrogen is added, both A and B produce orange PPT. So it means that the carbonyl group is present in both of these A and B. Now, and the second, the Toluene's reagent is added. The A produces a silver mirror PPT, and this B has no reaction. So it means that there is an aldehyde in this A, and it must be a ketone because it does not react with Toluene's reagent. Now this alkaline iodine is added. So there is no reaction in both of these. Now name the functional group present in both A and B. So if you see this, these both have carbonyl group because they both show a orange PPT with 2,4-dinitrophenol hydrogen. So carbonyl group. Now draw the structures of A and B in boxes. So if you see, A has a, this is their molecular formula. So they both have 5 carbons, and they they both does not have a reaction with alkaline iodine. It is actually the test for CH3. So and this A is aldehyde. So the A is going to be CH3. You can draw their skeletal formulas as well as their like this: CH3, CH2, 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 and C double bond OH. 1, 2, 3, 4, 5. So this is your aldehyde A, and for ketone, it's actually CH3, CH2, C double bond O, CH3, CH2, CH3. If you are uh, thinking that this this ketone could be attached to second carbon, but that's not going to be the case, because then there will be a CH3 group attached to the functional group, and it will give a yellow PPT, which is iodine, alkaline iodine. But this B is not giving any reaction with this alkaline iodine, so it means that this ketone is attached to the third carbon, and on this third carbon there is no methyl group attached. Okay, so you have to remember these conditions. Now C is a structural isomer of A and B. C is a straight chain change C is a straight chained and has 2 functional groups. Okay, C shows only one type of stereoisomerism. Now table 5.1 describes the observations when separate samples of C are added to different reagents. So C does not give a reaction with 2,4-DNPH, but gives a reaction with bromine and from orange to colorless. So it means it must have a carbon-carbon double bond, and it also gives this alkaline iodine test with alkaline iodine, but it told you that there is no carbonyl group. So the other molecule which gives a test with positive test with this alkaline iodine is actually this OH group. So these are your two groups which are present in C. One double bond, carbon carbon double bond, which is alkene, and the other group is alcohol. I told you that there are 2 functional groups. Okay? Now draw the structure of C. So C is going to be like CH3, COH. This OH group will be attached to the methyl group. Okay, that's why it will give a positive test with alkaline iodine. So CH3, CHOH, then CH2, CH, and double bond CH2. Now if you are imagine that this double bond could be on this third carbon 3, but that's not going to be the case, because then it will have give you this geometrical isomerism. But it told you that it shows only one type of stereoisomerism, and this molecule has only one type of stereoisomerism, which is optical isomerism. You can see that there is a carbon carbon. But if you draw this structure, CH3, COH, CH, CH double bond, CH, and then CH2. So this will give you a stereoisomerism, the geometrical isomerism as well as optical isomerism. But so both of these types of stereoisomerism are shown in this molecule. So this is a wrong molecule. Okay, this is your correct structure of C. You have to remember these conditions. Okay, now name the type of stereoisomerism shown by a molecule of C. So it's actually the optical isomerism is shown. Now part D. D reacts in the presence of sulfuric acid to form E and water. Okay, so the structure of E is shown. Now name the functional group present in E. So it's actually the ester group. Okay, ester. Now identify the type of reaction that occurs when D reacts to form E. Okay, so type of reaction. So it's actually the condensation reaction, because this ester is formed. Formation of ester. Okay, so in the when D reacts with sulfuric acid to form ester. Okay, so this is the condensation reaction. Now you are required to draw the structure of D. So now D must have both alcohol and carboxylic group, because only D reacts with this sulfuric acid to form this cycloester. So this D must have these both carboxylic group and alcohol group. Okay, so if I cut off the molecule from here, this molecule will be like this, and attached OH over here. Then you will have this molecule like this. Okay, like this. And if I attach another OH group, so this is your structure of D. Now let's rearrange the structure. So you will get like this structure, like this. OH, and that's your OH. So that's your structure of this D. Okay, this is your structure of D. So when this D reacts, it will form E with sulfuric acid. If the D reacts with sulfuric acid, it will form ester. Okay, now the infrared spectrum of E is shown in figure 5.2. Okay, now use the figure 5.2 and table 5.3. This is table 5.3 to predict two differences in the observations above 1500 of infrared spectrum of D compared to E. So this D has both carboxylic group and OH group, but this E does not have this carboxylic group or alcohol group. It has a ester group. Okay, so difference, you have to tell the difference. So this is the there is a ester group in this E, and there are carboxylic groups in D, and there is alcohol groups in D. Okay, so you will talk in terms of these molecules. Okay, these groups. Now what is the difference between D and compared to E? So D will have a peak of OH, and this OH is due to this hydroxy group. This is alcohol group, and this OH is also due to carboxylic group. So the peak at, so D will have peak at 3200 to 360 3600 due to hydroxy. Okay, due to hydroxyl group, due to alcohol. Now and D will also have a peak, will also have a peak at this due to this carboxyl group. Okay, this carboxyl group has this carbonyl group, carboxyl group. Okay, so peak at this 1670 to 1740 due to carboxyl group. Okay, carboxyl. And E will have the E will have or you can say that this E will have the peak at this 710 to 750 due to this ester group. Okay, you can write in terms of E, but I have written in terms of D. So I have written 2 points, so these are enough for 2 marks. So that's all for the day. This paper is completed, and I hope everything is clear to you. If you have any queries, you can ask me in the comments. And thanks for watching, and see you in the next video.